Assalamu alaikum. In our previous class, we have discussed interference of light. And today, we will derive some equations related to that when we see interference of light in an experiment. The experiment was conducted by Thomas Young. So it is famously known as Young's double slit experiment. So let us see what was the arrangement made by Thomas Young, and then we are going to derive the relation between phase difference and path difference. Then we will see the conditions for constructive interference and destructive interference, and then again we will derive an equation to find the fringe width of the interference pattern observed in Young's double slit experiment. So we are discussing Young's double slit experiment. Do you remember what was that? Thomas Young's double slit experiment. So there was a source of light and it was divided into two separate sources, S1 and S2. Why do we have to split one source of light into two separate sources? Why? Why can't we use two different sources? Suppose I use one bulb here, another bulb here. Will it give the interference pattern? Will it give?
It should be the same source, right?
It should be from the same source. Why? If it
There
is,
was a word I forgot that word.
yeah,
Like
otherwise the light rays will not be coherent.
yes,
Coherent
correct, correct.
means they must have almost same amplitude and their wavelength should be same, and they should have no phase difference, or if there is a small phase difference, it should be carried out throughout their propagation. So it is practically almost impossible to get two separate sources which are coherent. So what we do is we use a single source of light, and the light rays coming from them are divided into two using two narrow slits. So I have named those narrow slits as S1 and S2. And suppose the distance between these two narrow slits is A, small a. Okay, so these two acts as secondary sources of light. So according to Huygens principle, if we say there will be wavefronts coming and these 2 points will act as secondary source of waves, and you will get an interference pattern at a screen here which is kept at a distance, say D, from these sources. Okay, so this is kept at a distance D from these sources. Now suppose you have light ray coming from S1 and S2. If you consider a midpoint here, will the light ray have any phase difference? All the light ray coming from here and here, will they have any path difference? No, they have traveled through the same distance and reach here, right? So there will be no path difference and no phase difference. So here you will have a constructive interference or maximum intensity. So let me mark that central point as region O, because the light rays which are coming from both will travel the same distance and they will join together and they will have no phase difference. They will be in phase. So if two waves which are in phase add up, what you will get? You will get maximum intensity. The amplitudes add up, and so you will get a constructive interference or maximum intensity. So you will get that at the center region. Now, if you consider any other point, suppose I am considering a point P here. Okay. So the light rays that reach from S1 to P have traveled a distance S1P in this direction. And the light ray which have traveled from S2 to P have traveled another distance. So when you say path difference means the difference in distance traveled by these two waves. So let us find a relation between the phase difference and path difference. So relation between phase difference and path difference. What is path difference? That is the difference between the distance traveled by these two sources of light. Let me rub this S. You assume that there is a source of light which is divided into two. We may not need this S for our further derivation. So I have rubbed that part. Now, let us see what is meant by phase difference. In the beginning of this chapter, we told that any wave can be expressed by the equation y is equal to a sine 2 pi by lambda into ct minus x. Where if you have a wave like this, y means the displacement, x is the distance traveled. Yeah. And then what is A? What is A? The amplitude or the maximum displacement in y direction is the amplitude. And what is lambda? What is lambda? It is the wavelength. And what is C?
Velocity of light.
Speed of light. And what is T? The time.
Time.
And what is x? X is the distance propagated. So this is the general expression for any wave. Now here we are considering light as a wave. So let me express y1 as the displacement of a light ray that goes from S1 to P. So y1 is equal to A. Both have the same amplitude. So I will express it as A itself. A sine 2 pi by lambda Ct x1, and y2, the displacement of the light that goes from S2 to P, y2 is equal to a sine 2 pi by lambda Ct minus x2. Both have the same amplitude, they have the same wavelength because they come from the same source, and the speed of light, consider the experiment as conducted in vacuum. So C is saying, so at the same time they reach the point P, but the path difference, the difference in the distance travel will be there as x2 minus x1, which will be S2P minus S1P. So that will be the case. Now, what is meant by phase? Phase means this angle. This angle is called the phase. Sine of this thing, right? So this is the angle. It is called phase. So when two light rays reach there, what is the phase difference? Phase difference. Phase difference is
Y2 minus
represented
Y1.
by the symbol delta. So phase difference delta is equal to, I will take this angle minus this angle. That is the phase difference because this angle is called phase. So delta is equal to 2 pi by lambda into Ct minus x1 minus 2 pi by lambda into Ct minus x2. So let me just expand this lambda 2 pi by lambda and taking into the brackets inside. So I will then,
Teacher,
yes, you had it
teacher,
out.
what if Y2 is greater than Y1?
Y2 is no, may not
No?
be.
Why?
Y means the displace. Suppose from S1 to P, a wave is going, right?
Okay.
Y means the displacement from this Y axis. So it is continuously varying like a sine wave.
Yes.
Okay. But as you said, X2 will be more than X1 because from S2, it has to travel a longer distance to reach P. So here
Okay,
again,
sir.
another wave is going. So this wave must have traveled a larger distance. So we can tell that x2 is greater than x1, but we cannot tell y2 is greater than y1. Y is continuously changing like a sine wave. Y means in the y direction, up and down,
Yes,
vertical
teacher.
variation. It will continuously change like a sine wave with time. Okay?
Yes, teacher, understood.
Okay. So now we are taking the phase difference. These two waves go and meet the point P. We know that if they are in phase, they will give maximum amplitude, right? And if they are out of phase, means one goes up and at the same time other goes down, they will give minimum amplitude or destruction of the waves will happen. So before going to that, we are trying to find a relation between phase difference and path difference. Okay. So phase difference means this angle minus this angle. So let me expand this expression. So it will get 2 pi by lambda ct minus 2 pi by lambda x1. 2 pi by lambda x1 minus 2 pi by lambda ct. So minus times minus will become plus. Plus 2 pi by lambda x2. Okay. So that is delta. So delta is equal to this quantity. Now 2 pi by lambda ct minus 2 pi by lambda ct. I can cancel this. Then what I have is 2 pi by lambda x1. There is a negative sign. And 2 pi by lambda x2. There is a positive sign. Let me write the positive quantity first. So delta is equal to 2 pi by lambda x2 minus 2 pi by lambda x1. Here, let me take 2 pi by lambda common, which is outside. So, delta is equal to 2 pi by lambda into x2 minus x1. What is x2 minus x1? x2 minus x1 means s2p minus s1p. Or in other words, the difference in the distance traveled by the waves coming from s1 and s2, which is called the path difference. So x2 minus x1, I can write it as the path difference. So here I got a relation between phase difference delta and path difference, that is x2 minus x1. So I can write the relation between the phase difference and the path difference is phase difference is equal to 2 pi by lambda times the path difference. Is that clear? The relation between phase difference and path difference is phase difference is equal to 2 pi by lambda times the path difference. You will need to memorize this equation. This will be required for solving numerical problems and also for our further derivations. Is this part clear to you? This derivation? Say yes or no.
Yes, teacher, it's clear.
Yes.
Okay, so let me proceed and I will take this equation. I will mention it somewhere and we will use that for our further derivations. That is the relation between phase difference and path difference. So what was the relation? Phase difference one of the equations which we have derived now is that phase difference equal to 2 pi by lambda times the path difference. Where lambda is the wavelength. So this is an important equation which we will require. Now let us derive the condition for constructive interference. Constructive interference. What is meant by constructive interference? What is meant by constructive interference? When two waves of the same phase meet each other, what happens? The resultant wave will have maximum intensity. Suppose you have two waves. This is one wave, and if it meets with another wave which is in phase means their crest goes up together and their trough goes down together. So when they meet, when they superpose, what happens is their amplitudes add up and you will get a very large wave. So if this is A and this is A, so what you will have here will be 2A, or you will see a bright light in that region. That is called constructive interference. So for constructive interference to happen, we know that they should be in phase, which means the phase difference or the difference in angle should be equal to 0. So condition for constructive interference is that the phase difference delta should be equal to 0. Only if the angle difference is 0, they will constructive interfere. No, there are other possibilities as well. Suppose this is one wave and at the same time it meets with another wave which has come like this. Okay, they also go together. See, here it started from 0. Here this is 0. This angle is pi by 2. This is pi. This is 3 pi by 2. Here you have 2 pi. So even if the phase difference is 2 pi, that can interfere constructively. So the phase difference can be 0, 2 pi. Suppose there is one more. After 2 pi, it will again go, right? So at 4 pi, again the wave will repeat. So even if the phase difference is 4 pi, they will undergo constructive interference. So if the phase difference is 0, 2 pi, 4 pi, etc., even multiples of pi, what happens? There will be constructive interference. So the condition of constructive interference is that the phase difference should be an even multiple of pi. In other words, we can write this as equal to n pi. Delta is equal to n pi, where n is equal to 0, 1, 2, 0. I can write this as delta is equal to 2n pi because even multiple of pi. Where n is equal to 0, this will be 0. If n is equal to 1, this will be 2 pi. If n is equal to 2, this will be 4 pi. So this is the condition for constructive interference to take place. We got the condition in terms of the phase difference. So let us find what is the condition for constructive interference in terms of path difference, where we just have to put here in this equation instead of phase difference 2n pi. So let me put instead of phase difference 2n pi is equal to 2 pi by lambda into path difference. So path difference I am expressing as x2 minus x1, or it can be S2p minus S1p. So here the condition for path difference is 2 comes on both sides. I can cancel. Pi comes on both sides. I can cancel. When I take lambda to this side, it will go to the numerator. So I have n lambda is equal to x2 minus x1. Or the condition is that the path difference should be equal to n lambda. X2 minus x1 is path difference, that is equal to n lambda. So this is the condition for constructive interference, or you can also write it as 2n lambda by 2. So the path difference should be an even multiple of lambda by 2. So did you get the condition for constructive interference? What is the condition for constructive interference? Either you can say that the phase difference delta is equal to 2n pi, or you can tell that the path difference should be equal to n lambda, or 2n by lambda by 2. You can tell that the phase difference should be an even multiple of pi, or the path difference should be an even multiple of lambda by 2. Is this part clear to you?
Yes, teacher.
Say yes or no. I didn't get you, Irfan.
Yes, teacher.
Yes,
Yes,
teacher.
yes. Clear.
Yeah, so if this part is clear, let me continue. Just remember the condition for constructive interference. Phase difference should be even multiple of pi, and path difference should be even multiple of lambda by 2. Just to put it as even, to remember that easily, I'm telling, because it also have to do with the other thing which we are going to see now, the condition for destructive interference. What is meant by destructive interference? What will be the resultant intensity after destructive interference? You don't remember? It is always better to go through the textbook or watch the lesson before you come to the next lesson, because many of what we discuss in today's lesson will be a continuation of what we have learned previously. So it will help you understand the class better. So condition for destructive interference means the dying of the waves. Suppose two waves. One wave is like this, and another wave at the same time is like this. See, here when the crest goes up, the trough goes down. So if they combine, the result will be nothing, no intensity or minimum intensity. The amplitudes will cancel each other, or there will be dark. There is no bright color, dark. Constructive means high intensity or bright color, while destructive interference means there will be no intensity of light or minimum intensity of light or dark. So this occurs when the light rays that come together are out of phase by 90 degrees. Or in radians, we can tell that the phase difference is pi. Here, you know this angle is 0. This is pi by 2. This is pi. This is 3 pi by 2. This is 2 pi. So when this wave comes, the other wave have reached this point. So the phase difference is pi. or 90 degree. So here it starts. So it starts from pi, right? So the phase difference is pi or any odd multiple of pi. So here the condition for destructive interference is that the phase difference delta should be equal to pi, or you know the trough again comes when it is 3 pi. So 2 pi the wave repeats. So when it is pi the trough start coming, and again when it is 3 pi again the trough start coming. So every odd multiple of pi, what happens? There will be destructive interference, etc. Now this is equal to, do you know how can I express in terms of n an odd number? Even number we expressed as 2n, where n is equal to
2n plus
0.
1.
Yes, 2n plus 1. Exactly. So delta is equal to pi to 3 pi, 5 pi, because in every odd number it will repeat. As Zaman said, we can express an odd number as 2n plus 1 times pi, where n will be equal to 0, 1, 2, etc. So if n is equal to 0, it will be pi. If n is equal to 1, 2 times 1 is 2, plus 1, 3 pi. So if n is equal to 2, it will be 5 pi, etc. So this is the condition for destructive interference. So you can remember that the condition for destructive interference is that the phase difference should be an odd multiple of pi. The condition for constructive interference was the phase difference should be an even multiple of pi. Now let us see the same condition. What happens if we apply to this equation? We will get the condition in terms of path difference. So putting here, instead of phase difference 2n plus 1 pi, I will get 2n plus 1 pi is equal to 2 pi by lambda times the path difference, that is x2 minus x1. Okay, so here you have pi getting cancelled, and I will take lambda to this side. It will go to the numerator, 2 to this side, it will come to the denominator. So lambda by 2, 2n plus 1 is equal to x2 minus x1. What is x2 minus x1? That is the path difference, that is S2p minus S1p, right? So I can say that the condition for destructive interference in terms of path difference is that, I'm writing this as path difference. So path difference is equal to 2n plus 1 times lambda by 2. So this is the condition for destructive interference, that the path difference should be an odd multiple of lambda by 2. So we have learned today a relation between phase difference and path difference. Phase difference is equal to 2 pi by lambda into path difference, and we have learned the condition for constructive interference and destructive interference. Constructive interference, the condition was that the phase difference should be an even multiple of pi and the path difference should be an even multiple of lambda by 2. While the condition for destructive interference is that the phase difference should be an odd multiple of pi and the path difference should be an odd multiple of lambda by 2. Can you remember those equations? Can you remember these equations? It will be useful for solution of numerical problems. So I will continue. Now we are going to derive an equation for the separation between two fringes. We saw in the last class that the interference pattern will be dark and bright fringes or bands, right? So let me redraw this equation. This figure, I'll redraw this figure. Here we have light coming from a single source divided into two slits. The two slits I'm just showing you by dots because they are very narrow, S1, S2. And suppose the separation between these two slits is A. One of the conditions for interference to happen is that the slits should be placed very close to each other, which means A is very small compared to the distance of the screen from the sources, which I note as capital D. So here in the midpoint O, what will you have? Will it be constructive interference or destructive interference? In the middle region here. At O, what will you have? Will it be constructive interference or destructive interference? See, both the light ray from S1 and S2 have
Constructive, right?
traveled. Yes,
Constructive.
constructive. Travel the same distance. So the path difference is 0. So there will be constructive interference, or at O, you will get a central maxima. It is called a central maxima. Okay, then at another point P, we will get either a maxima or minima. Okay, so at point P, we will get either a maxima or a minima. So what we are going to do now is find out an equation that will give the separation between two maxima or minima. So we will do that in the next class because there will not be enough time for the full derivation. So we will